Alright, number 42, carbon dating. Carbon 14. So we have carbon 14, its half-life, 5715 years. So 1,500 or 1,715 years. All right, so now it says a piece. If it's true, here's what it says: carbon-14 dating assumes that the carbon dioxide on Earth today has the same radioactive content as it did centuries ago. So that basically the fundamental properties of carbon dioxide has not changed at all. And if this is true, the amount of carbon-14 absorbed by a tree that grew several centuries ago should be the same as a tree that grows should be the same as it is today. A piece of ancient charcoal contains only 15% as much of the carbon of a modern piece. So the ancient has 15%. And our job is to figure out how long ago was the tree burned to make the ancient charcoal. So we need a model of some kind. Now, do I know what my K would be? So we can use that. We can use natural log of 0.5 because that would be for half-life, and the half-life of carbon-14 is 5,715. So now I know y is equal to CE to the natural log of 0.5 over 5715 times T. Now, do I know what the initial amount of carbon was? We're still talking in percents, aren't we? Because it says we're trying to figure out how long it takes to get down to 15%. So what would be the original amount of carbon-14 in that piece of wood? 100%, or 1. So y would be equal to 1 times e to the natural log of 0.5 over 5715 t. And now we want 0.15 is equal to e to the natural log of 0.5, 5715 times t. And we want to solve this for t. Now, we could take the natural log of both sides. If we do that and set up something nice and easy, natural log of 0.15 is equal to, if I take the natural log of e, what am I going to get? It cancels out, which is why we want to do it, right? So if I take the natural log of e, that's gone. I'm left with natural log of 0.5 over 5715 times t. Then what do I have to do to get t by itself? Multiply by the reciprocal. So t would be equal to this. Now we want to throw that into a calculator. So 5715 divided by natural log of 0.5 times natural log of 0.15. So I got my time. If the assumptions are correct, then that piece of charcoal is 15,641.8 years old.